So let's go to the resultant of parallel forces. So since we know already the concept behind getting resultant force, so we also know how to get the the resultant of vertical forces, horizontal forces, and getting the resultant of the combination of your horizontal and vertical components. So let's proceed with resultant of parallel forces. Okay, so resultant of coplanar. So we'll be discussing coplanar because if it's non-planar, so that will be an advanced topic already. So coplanar forces are, of course, those forces on the same plane. And if you define parallel, so meaning the direction or the action of line of which are parallel. So meaning it could be in this direction, so they are parallel. It could also be in the horizontal aspect as long as the line of action is the same. Okay. So usually we in the design of structures, so we usually um, analyze parallel forces, especially in the slab, because the distribution of the slab forces is vertically going downwards, and then parallel yung distribution. Okay, so the resultant of your parallel force, so it can have the magnitude, the direction, and the position is, of course, that will be coming from the resultant of your parallel force system. So kuha na siya ng the combination of all parallel forces. So it gives us the ultimate resultant force. Okay, so let's see. Kaya wag na chat kita sa mayang concern. Kuha, nag-record ako sa OBS actually. Okay, so the position of the resultant must be determined to produce the effect. So how do we determine the resultant? So we get the different summation of forces. So I think the same concept as before, but we will be utilizing it in a parallel system. So puro siya mga vertical forces or it could be horizontal forces depending on the structure. So as you can see here in the formula, so the resultant is always the same. The resultant formula is the same as what we have discussed before. Okay, so since we have discussed the moment of a force last meeting, so in order for us to determine the location of the resultant of the parallel force, so we will be using the equation for the moment. Because in the equation of the moment, notice that there's a term here which is the distance, and I think we can determine the distance through this equation. Okay. So usually the ultimate or the sum or the resultant force is will result to the ultimate moment or the optimal moment, and that moment is the sum of the other moments in the parallel system. So maglibog siya on, I think it's difficult for you to apprehend because it's purely kanang kuan siya kanang scientific term or engineering term, but I think you can appreciate it once we go to the examples. Okay, so one example for your parallel force system is in this manner. So for example, you have different forces in parallel. Okay, so for example, this is point O, and we take a moment about that particular point. So in order for us to determine the resultant, so the resultant will be in this direction. So let's say we assume it first because we don't know the the system is all right, or I mean if the resultant is in this position. But of course, upon determining the distance d, so we can adjust fully the location of your resultant force. Okay. So also take note that the direction of your force, so it may be parallel, but not all the time that these forces have the same direction. So for example, the same direction here is only force 1, 2, and 4. Then the direction of the third force is going upwards. So even though they are parallel, so it's not necessarily that they will have the same direction or the same line of action. So if we take moment about point O, so notice that we don't have any distance for force 1, but we have a distance for force 2, force 3, and force number 4. So meaning when we take moment about O, so force number 1 is being neglected. So what if we take moment about point F, I mean F sub 4. So meaning the process will be reversed, and then we're going to have distance here from, let's say, point A niya. So this becomes distance x3, this becomes distance x2. So sorry for my drawing, warag kuan siya no sa inyong standards. And this becomes x sub 1. So again, the distances will depend on where you are taking your moment about. Okay, so again, the distance of your resultant force is still approximated because we don't know the true distance of this one, and we still have to determine the value of your distance for the resultant force. Okay, so again, same thing if we take moment. So I think if you can recall from the last meeting or previous meeting, so everything that is rotating counterclockwise is positive. Everything rotating clockwise is negative. Sakto, negative? Negative. Okay. So in engineering terms, so for example, we have, so kaning mga figures here, in the figure here, rectangular load, triangular load, trapezoidal load, and this one is a mix of rectangular and triangular load, kaning trapezoidal. So this is what we normally do in civil engineering. So we analyzed uniformly distributed load. So that's what we call it as uniformly distributed load. Okay, so I think this won't matter, but I think the only thing that matters here is the location of the resultant force. So if it's rectangular load, so as you can see, since it's a box or a rectangle, so the location of your resultant vertical force will be at the center. So I think it will be on the centroid or at the center of gravity. So if it's triangular load, so it will likely most be in the 1/3 location of the triangle or at the center of gravity of the triangle. That will be 1/3 from the base or from the length of the base of the triangular load. So if you have mixed load, so instead of um, determining it with this one, so I think this one is just approximated because usually in the trapezoidal load it will depend on the degree of the load being presented. Okay, so you may break it down into two different components. So you may break it down first in this manner. So one is rectangular, another one is triangular. So the one force here is at the center, and the second force it is at the 1/3 of the triangle, and then you take moment at a certain point to get the resultant of your force. Okay, so I think that's what's important here is you know how to locate later the resultant force of your coplanar parallel force system. So let's try to discuss examples for us to appreciate the problem. Okay, so let's go first to number one. So number one is in a parallel force system acts on the lever shown in the figure. So determine the magnitude and the position of the resultant. Okay, so we have a parallel system here. So we have three forces going downward, and we have point A here. So usually this can also be called as a overhang or a cantilever. So overhang or cantilever. So that's why it's also a lever here. So dili lever ka ng organ na. Cantilever, or I think it's lever if it's one word. All right. So looking at the forces, so we have 30 here. We have 60 going downwards. We have 20 going up, and then 40 going down. So most likely if you're going to observe the different values, so 30, 60, and 40 are all going down. So most likely the resultant is also going downwards, diba? Because what's against the three forces going downward is only a 20-pound force going up. Okay. So let's say our resultant will be in this direction. So since we don't know yet the exact location of your resultant, so let's say this is the 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 location of my resultant force. So let's say R. Okay. Okay, so if we take moment about A, so moment about A, so what happens is that, so let's try to, I'll adjust something. So if we take moment about A, so again, if going through the first force, this one is the first distance, so that will be a positive um, positive rotation for the 30-pound force. So we have, so that will be negative 2 times 30 since we are having a clockwise rotation. And then minus, so still minus because we are having a clockwise rotation. So that will be, so this time the second distance is now 5. Okay, 5 feet. So that will be negative 5 times 60. Okay. And then next is the counterclockwise. So that will be positive. So that will be 7. So we don't want to disturb the resultant force yet because we'll be determining that one later. Okay, so next is um, plus 7 times 20, and then minus, so that will be minus because the moment from the last force is clockwise. So that will be 2 times 2 plus 3 plus 2 plus 4, that will be 11 times 40. Okay, so moment about A is equivalent to, so if we try to calculate that one, so that will be 660 pound per foot. Okay, so again, this is negative, or if you don't want to place the negative as the answer, so you can also have it in this manner, 660 pound per foot, and then the put the rotation clockwise. Okay, so of course, how do we determine the resultant force? So of course, the resultant, so let's say R is just the summation of the forces vertical, di ba? So that will be negative 30 since it's going down, negative 60 plus 20, then minus 4t. So the resultant force is equal to, so that will be negative, pila man siya, negative 110, di ba? That will be negative 110 pounds. So this is negative 110 pounds. But our problem here is where is the location of your resultant force. So again, you can express your final answer for the resultant as arrow form. So ana siya. So it could also be that. So it could also be shown in that manner. Okay. So next is what's left for us to do is we need to determine the distance of your resultant force. So how do we determine that is, of course, we can also use the moment about A, but this time we are going to be um, getting it from the resultant force. So instead of the different components, so we're going to get it from the resultant force, which is R times the distance D. Okay, so this is the distance D here. So where do we get M sub A? So M sub A is this one, what we have solved earlier. And then R is in this direction. So what is unknown for the equation is now the distance. So we're going to have negative 660 pound per foot. Then we have negative 110 pounds times the distance D. So 660 divided by 110 is 6 feet. So distance is equal to 6 feet. So notice nga murag na jackpot siya, di ba? So it's at the center. So that's exactly 6 feet. Ba? So for us to summarize what we did in the problem, so let's try to use another color. So first is we took moment about A. So using the component forces, meaning the individual forces. So using component forces. So that's why we have 4 different moments here. And then second is we use getting the resultant force, uh, summation of vertical forces. Since all our parallel forces are in the vertical direction. And then lastly is we um, got a distance using the moment using moment through the resultant force. Okay, so if you try to compare, so so if you try to compare the moment of, so let's say you want to get the moment of A using the resultant force, so you can verify that the moment about A using the resultant force 660 times the distance, dili siya 110 I mean. So 110 times the distance 6. So the moment is negative 660 pound per foot, which is the same as the individual components being summed into one big moment. Ba? So this one is just using the force and the distance of the resultant force. This one here is using the forces and the distances of the component forces. So it leads to the same answer of the moment. So one is using individual forces. So let's say its component forces, and then the other one is using the sum force, which is the resultant force, as a moment or a driving arm. Okay, so I hope you understood this problem. So do you have questions? Okay, so I think there's no question. So let's try to proceed to number 2. Okay, so for number 2 is we have the same system, parallel forces, parallel force system. And this time our point is at the middle, point O. So not totally at the middle because the distance on the left is 6, the distance on the right is 8. Okay. So again, analyzing the system. So we have um, two vertical forces going down. Okay. And then two vertical forces going up. Right? So if you want to reverse the process also, so you can also solve first for the resultant vertical force. So resultant vertical force is equal to the summation of forces vertical. So you can also do this as your first method. Okay, so 50, so that will be negative 50 since it's going down, plus 40 going up, plus 20, and then minus 60 going down. So the resultant force for the system, so that will be negative 50. Sakto ba no? So that will be negative 50. So negative 50 pounds. Or in arrows, so that will be 50 pounds. Then you write the arrow going down on the right side. So that's the resultant force, 50 pounds going down. So again, since we don't know the location of the resultant force, so let's try to assume first that it's at the center. So again, I'm not sure if the location is at the center, di ba? Or let's make it an offset because we need to have a certain distance from point O for the moment to work. So let's say it's at this distance. So let's say it's here, so that we can have a distance of d here later. So resultant is 50 pounds. Okay. So next is we take moment about point O. So moment about point O. So summation of moments about point O. So equals to, so starting with the first force, the 50 pounds. So this one is the distance of the 50 pounds from point O. And if you imagine the rotation, so that will be counterclockwise. So that will be force times the distance. So that is positive rotation, counterclockwise. So next is this distance here. That will be 2. The distance of the 40-pound force from point O is 2 feet. And the rotation, so again, if you try to push the tail of the 40-pound, so the rotation is clockwise, so that will be negative. So that's 40 times 2. So next is the 20-pound force. So again, if you put the distance at the tail of the force, and if the distance pushes the tail, so you can imagine the rotation. So it will have a counterclockwise um, um, rotation. So that will be positive rotation, and we have 20 times 3. So lastly is your 60-pound force. So if you try to put the distance at the tail of the 60-pound force, that's 8 feet. So the rotation is clockwise, and that's negative. So that's 60 times 8. Okay, so the moment about point O is equal to, so that's equal to 200 pound per foot. So 200 pounds per foot. Okay, so getting the moment again. So this time with respect to the resultant. So resultant force times the distance d. So resultant force is 50, and then distance is d, diba? So this one is negative 50. Then this one is also negative. That's negative 200, or that's 200 pound per foot, and then the rotation is clockwise. So incorporating it here again, so we have 200 pound per foot, so negative. So divided by 50, so the distance is 4. So d is equal to 4 feet. Okay. So since the resultant will create a negative moment, so it is likely to be placed on the right side. So the exact location for your resultant force and the distance will be 4 feet, which is in this area here. So this will be the 50-pound force, and then this will be the distance d, 4 feet. Okay. So again, if we try to sum up our solution, so first is we got the resultant of the vertical force. So summation of forces vertical. Then we took moments about a point O using the component forces or the individual forces. And then getting the distance by using the moment about point O through the resultant force. So if we try to number our solution, this will be number 1, this will be number 2, this will be number 3. So the moment of 200 pounds is going here. The resultant force of from number 1 will be going to here. Then the unknown distance is the only unknown parameter is the distance. So that's why we got 4 as the answer. All right, so questions or clarifications? Okay, so I think there's no question. So this is the solution for number 1 and number 2. Okay, so let's proceed to the next slide. So let's try to solve the examples 3 and 4. So this time is muna siya usually ang among isolve sa CE. So these are structural components. So let's say this is a beam support, and the number 4 is a truss. So usually what we can find the truss in our roof structures. So muna siya ang mga trusses. Okay, so let's try to solve first number 3. So the beam AB in the figure below supports a load which varies at an intensity of 220 Newton per meter. Then going towards a 890 Newton meter. So this one is a trapezoidal load. So calculate the magnitude and the position of the resultant load. So earlier, as what we have seen in the previous slide, so we can divide this one into a rectangular load and a triangular load. Okay, so this one is 200 Newton, this one here, 220 Newton. And then the upper portion from 890 on the left side minus 220, so that becomes 670 here, triangular load. Okay, so we have two different forces. So if we try to draw the different forces, so let's make use of another color. So let's say this one is our rectangular load earlier. So again, this is the 220 Newton per meter, 220 Newton per meter, and this is 6 meters. So meaning if you want to determine the force being generated by this one, so as you can see, that's Newton per meter. So you just have to multiply it with a distance. So that will be 220. So the force, the vertical force for this one, so let's say F sub 1 is equal to 220 times 6. And then the answer is 1,320 newtons. Okay, so again, since this one is a rectangular load, so the location of the resultant is at the center. So that will be at the center. So this is the 130 newtons resultant force of that particular uniformly distributed load. Okay, so next is we go to the triangular load. So triangular load, so this will be so from 890 minus 220, so that will be 670 Newton per meter. So again, let's say this one is 6 meters. So getting the second force from the triangular distributed load, so that will be 670, 670 times 6. So that will be 4,000. So that so di siya mauday. So aside from is wrong. So to determine the force, so the correct way is to get the area there. So the area earlier here is base times height, so that will be 220 times 6. So this one is 1 half base times height. So base is 6, the height is 670 Newton per meter. So 670 times 6 divided by 2. So the answer is 2010 newtons. So the resultant for this one is at the 1/3 of the base. Okay, so 1/3 of 6. So that will be 2. So this one is 2 meters. Okay, so this one is 3 meters. Or from the other side, that's 3 meters. And then the other side of this one is 4 meters. Sakto ba? Um, okay, so again, for if you have uniformly distributed load, so let's try to write it here. So if you have uniformly distributed load, uniformly distributed load, such as the given figure above. So in order to solve for the force, just solve the area of the given figure. Solve the area of the polygon. So this one, the 220 here is the height of the rectangle here. Okay, so most likely if we try to draw the resultant force, this is at the center, and then this is at the 1/3 of the. Okay, so for the location of the resultant force, so I think before we try to solve this one, so since this one is supported by a pin and a roller, so of course these have reactions here. Diba na siya reaction niya? But since we're not interested in that portion yet, so what we need to do is just to ignore the supports first. So we'll try to go to the supports in a different topic. So let's try to isolate first the resultant force in a bar first. Muna siya isolated lang siya sa diagram. Okay, so let's say this is 6 meters. Let's say this is the resultant force of the triangular load. And then this one is the force of the rectangular load and then triangular load. So this one is 2010. This one is 1320. So 3 meters, 2 meters, and then this one is 1 meter. So point A, then point B. So following the concept earlier, so solving first for the resultant. So resultant is equal to summation of forces vertical. So that will be negative 1320 minus 2010, since both are going downwards. So the answer for this one is negative 3330. So newtons, or 3330 newtons, then going down. So next is we need to determine the moment about a certain point. So it depends on you on where you want to place your where you want to create the moment. So it doesn't matter because it will give us the same answer. But as long as when you get the moment with respect to the resultant force, it should be consistent that it's always from the same point. So if you're going to get the moment of the component forces from point A, so if you determine the distance of the resultant, so it's also coming from point A. So point B for the component forces, point B also for the resultant force, because again the distance will be coming from either point. So maybe your distance is based from point B, or your distance is based from point A. Alright, so let's say so I'm going to show you the both lang siguro para you can compare. So moment about A, so let's start off with A first. So that will be 1320. So that will be negative because the rotation is clockwise. So 1320 times 3, then minus 2010, and then times 4. So the total moment so total moment is negative 4080. So that's Newton per Newton meter. Okay. So next is we get the distance based from the moment of the system of the component forces and the resultant force. So again, this one is going through here, and the value here is going to the moment of A. So the unknown is only the distance. So negative 480 is equal to 3330 times the distance. So that's negative. So the distance is 1.23 meters. So sakto ba siya? So distance is 1.23. So I think Murag dili siya correct no eh, because if it's 1.23 from point A, so that will be only from here, di ba? So this is one, let's say that is 1.23. So let's compare it with taking moments about point B. So if it gives the same answer. Okay, so I'm going to place it here. So if from point B, so notice that our force will be from point B now. So starting with um, the first force, that will be 2010. So that will be times 2. Okay, so times 2 only because this is the distance from coming from point B, and it's counterclockwise rotation plus 1320 times 3. So summation of moments about point B. So let's try if we get the same answer. So that will be 7,980 Newton meter. Okay. So atong tanaw na if our answer basta ko lagi ni siya then times 2 ra. So maybe nasayop ko sa akong pag-calculate. So let's see. Okay, sayop yun siya. So this is 12,000. So 12,000 negative 12,000. So divided by 3330. So that is 3.6. So kani siya murag mo make sense na, di ba? I think it will make sense. So let's say 3.6 is in this location here. But this is 3.6 from point A. So don't forget also that to place a description here, 3.6 meters from point A, since we are determining it from point A or taking moments about point A. So let's go to point B now. So going back to point B, so I think this one is correct already. The next is getting the distance from point B and the resultant force. So again, this one is here. Then 3320 will go to R. So you have 7,890. Then you have 3330 times the distance. So 7,980 divided by 3330, that's 2.4. So the distance is 2.4 meters from point B. Okay, so this one is 2.4 meters. So if you try to add up this one, 2.4 plus 3.6, 2.4 plus 3.6. So that will be the entire span of the given bar, which is 6 meters. Okay. So I think your answer will only differ on where you are getting your moments about. Okay. So So sige lang para ma-uniform mga to answer in the exam later on. So we'll be stating it in the problem where you will take your moments about. Para of course din sa maglabad na. Alright? Okay, so again, here is in this example we just added an extra step by getting the component forces. And the next is we got the resultant force. The next is we got the moments. So it could be a moment from A or moment from B. As long as you place a description at the end of the answer if you have more than 2 points. So in the previous example, so since we only have point O and point A and there is no other point, so it's okay that we don't have any description, but pili sa ninyo i-describe sad like to the right of point A, to the left of point O, and so it could be that description also. All right, so questions? Okay, so I think there's no question. Okay, so let's proceed with the next example. So next example is this one. So let's go to the truss. So again, neglecting first the reaction forces of your pin and roller. So we'll get onto that in the later topics. So what we're about is just the location and the position, the magnitude and the position of the resultant force. So for you to be not confused, so just try to create a straight bar or a straight line para ma-ignore ninyo ang figure. Okay, basin it's complicated for you to look at. Okay, so just try to place it here. And this one right here. Na, ang isa dire lang sa ubo siguro, di ba? And here. Na, para di mo maglibog kayo. So this one is 890 newtons. Then this one is 1335 newtons. 8900 newtons. 1780 newtons. 1335. And then 890 newtons. So just bear with my drawing lang kay. Kibaw ko bati siya. Okay, so the first thing to do is again to get the resultant vertical force. So getting the resultant force. So summation of forces vertical. All right. So that will be negative 890, then negative 1335, negative 1780, negative 1335, negative 890, negative 8900. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 forces in total. So resultant force is negative. So let me calculate it first. So that will be negative 1513 Newton. Or in arrow, so you can have 1513 Newton, then arrow going down. All right. So first step done. So again, you may you may take moment about point A. So let's go to point A first. Then let's compare it with point B if it gives us the exact location of the resultant force. So moment about point A first. That will be so of course the first force here from point A is neglected because there's no distance being involved for 890 Newton on this portion because again there's no distance, diba? There's no horizontal displacement or horizontal distance involved going towards that particular force. Okay, tunong naman siya sa point A, di ba? So next is your 1300. So this one is point A. So next is 1300. So that's negative 1335 because we will have a negative moment because the rotation is clockwise. So the distance is yet unknown because we don't know the distance here, di ba? This is an unknown distance. So how do we get that distance? So we're going to use a right triangle. So we have to solve first for the other distances. So notice that this one is 30 and this one is a 90-degree angle here. Okay. So isolating first this triangle here. So since this one is 30 degrees, this one is 90 degrees. So how did I know that it's 90? Because the bar is perpendicular sa kaning kan. So base nalimtan na sa nina ko butang og perpendicular sa. So but is perpendicular. So this one is 3 meters. So the best option for us to do is to solve for this distance here on the left side. So since this one is the hypotenuse, so we'll be utilizing the cosine function because that is adjacent of the angle all over the hypotenuse. So cosine 30 degrees is equal to the unknown distance. So let's say x all over 3. So that will be 3 cosine 30. Then the answer is 2.6 meters. So this distance here is 2.6 meters. So next is we're going to isolate this triangle here. Ano siya? So isolating this triangle is we have 2.6 meters. This one is 30 degrees. And this is the unknown distance that we need to get, which is x sub 2. So again, that will be cosine function still. Cosine 30 degrees is equal to x sub 2 all over 2.6. So x sub 2 is equal to so that will be 2.25. 2.25 meters. So this is 2.25 meters. So next is the 8900 force. 8900 times 3 still clockwise rotation minus 1780 times, so since the figure is symmetrical or it's a mirror image of, if you slice this one up, so the distances covered by the other portion is the same, di ba? So that's what we call asymmetrical. So this one is 4.5. Okay, so if you divide this one, so this one is 1.5, 1.5. So of course, the distance here is also the same, di ba? This is 2.25 also, cutting right triangle here. So since this one is 2.25, so the other distance is 0.75, diba? 0.75, this is 0.75. Okay, so next is 1335 times, so that will be 3 plus 3 plus 0.75, that will be 6.75. Then lastly is the 890 Newton force on the far end, which is at point P, 890 times 9. Okay, so the moment about point A is equal to, so ako lang calculate, relax lang mo diya. Basta inigabot sa exam, okay, kamo naman sad. Okay, so the total moment of the system is 54,735, so negative, Newton per meter, or 54,735 Newton meter, then rotation is clockwise. Okay, so if we're going to solve for the distance of the resultant from point A, so resultant times the distance. So again, the moment of A is coming from the previously answered equation. Then the resultant is coming from here. So that will be 54,735 then 15,130, and then distance. So distance is 3.62 meters from point A. Okay, so most likely, since this one is 3.62, so most likely it's at this location here, the resultant force. This is 3.62. So let's try comparing it with the moment at point B, if it's the same, if the location is the same. So let's write it here. So moment at point B is equivalent to, I think it's the same, but since the figure is symmetrical. So starting off with from right to left ata, so 1335 times 2.25. So this time is we're going to have positive values for your moment, since all moments will be in counterclockwise direction, plus 1780 times 4.5, and then plus 8900, so times 6, and then plus 1335 times 6.75, and then lastly is 890 times 9. So moment about point B. So moment about point B is 81,435 Newton per meter. Or 81,435 Newton meter, and then counterclockwise rotation. Okay, so if we're going to solve for the moment about point P, I mean the resultant from point P. So again, this one is here. The resultant is going here. So that will be 81,435 is equal to 15,130 and times the distance. So distance is negative 5 point, so this one is negative 5.38. So meaning it's going to the left, diba? Okay, negative distance man. Oh, if integer pa na, so negative values are on the left of the zero. Diba? So distance is 5.38 to the left of point B. So meaning this one is 5.38. So 5.38 plus 3.62. So that is equivalent to 9. So meaning either way, so our solution is correct. So if we're coming from point A, so we got the correct answer. If we're coming from point B, we also have the correct answer as well. Okay, so do you have questions? Okay, so no questions. So by next meeting is we're going to have our last topic before the midterm exam. And then, of course, I'll give you an assignment again for this topic so that you can review the concept that I have discussed today. Okay.